Hello and welcome back to Mrs. Law's class. In this video, I'm going to show you how to do an application problem for a parabola. So here are some pointers to help you with the application problems. Always draw a picture using the given information. That way it'll help you to visualize where all the values are. Next, draw in the x and the y-axis, preferably with the vertex on one of the axes or even at the origin, so you don't have to worry about the h value or the k. Next, you will usually know a couple of points from the diagram, so set up the equation of the parabola and solve for a by substituting these known points into the equation. Alright, let's take a look at an example. The central cable of a suspension bridge forms a parabolic arch. The cable is suspended from the top of two supporting towers 250 meters apart. Now, I've already drawn part of the picture, just to speed it up a little bit. And we know that from tower to tower, this is 250 meters. So let's write that down. The top of the towers is 50 meters above the road. So this is 50 meters. And what we'll do is we'll assume that this line here is going to be the road. And the lowest point on the cable, so that would be the vertex here, is midway from the towers, which means that this distance here must be 125 meters. And then this vertex is also 3 meters above the road. So this distance here is 3 meters. Find the height of the cable above the road when it's 30 meters from one of the towers. So what we're doing is we're looking for a point here so that this distance is 30 meters and we want to know what this height is. So I'm going to actually show you two different ways to do this. And the first one is we're going to put the vertex on the origin. All right, so what we're going to do is I'm going to draw in my x and y axis right through the vertex. So this is my x and my y axis. Okay, so by doing that, we know that we are going to use the equation y equals ax squared. All right, so what point do we know? Well, we can see that we have the vertex, which is 0, 0, so that's fantastic because we don't have to worry about our h and our k. But we also need a point. Now, we do know this point up here. And the reason that we know that is we know that the horizontal distance from the vertex to the tower is 125 meters. And we also know that the height of the tower is 50. However, since the vertex is 3 meters higher, we're going to have to subtract 3 from the 50, which means that the y value will now be 47. So we're going to plug that into our a value here. Or sorry, not into the a value. We're going to plug a point into x and y. So we have y is 47 equals to a times 125 squared. And then we're going to use our calculator to calculate this. And a will equal to 47 divided by 125 squared, which is 15,625. All right, so now the next thing that we're going to do is we're going to write our equation, and I'm going to do that over here. So we have y is equal to 47 over 15,625 x squared. Now, we haven't actually answered the question yet. So the question is asking us to find the height of the cable above the road when it's 30 meters from the tower. So we are looking for this h value, minus 3 here, okay? So what we have is the 30, which we know is the distance from the tower. Now, when we are measuring a point, we always have to measure from the origin. So this point actually isn't going to be 30. So we're going to go this way to find our x value. And that means that our x value is going to be 125 minus 30, which means that this point here is going to be 95 and y, which we don't know. So we're going to plug the 95 into our x. And because we already have the equation, we can then use it to find our y value. So y is equal to 47 over 15,625 times 95 all squared. And plugging all of this into our calculator, we get 27.147. Okay, now remember that is a point that is based on our x and y axis. So that y value actually is only the height or the distance from here to my x-axis. So we need to take this number, the 27.147, and we actually need to add another 3 meters to get the height above the road. Because remember, the road is actually this bottom black line here. So adding that together, we get 30.147 meters above the road. All right, the next thing I want to show you is what happens if we put the vertex at a different spot. Let's say that we choose the vertex on the road this time. Okay, so I'm going to erase my axis, just my x1, and this time I'm going to place it right over here. So this is my x-axis. So from here I can see that my equation will now be y equals a x squared plus k, because my vertex has actually moved up. Now I can actually now use the same point, except that instead of 125.47, that point is now going to be 125 and then 50, because that will be the whole height of the tower. So now we have 50 equals to a bracket 125 squared plus, and I can see that my k value has moved up 3. So the vertex has moved up 3, so k equals 3. So I'm going to solve. So you get 47 equals a, and then we leave this as 125 squared, and you can see that the a value ends up being the same as before, 47 over 15,625, and it should be because it's the same width. So the parabola has not gotten skinnier, it's actually the same width parabola. So plugging this into and creating my equation, I get y equals 47 over 15,625 x squared plus 3. Now my x, again, is the same value as before. It is still a horizontal distance of 95 away from my origin. So this is the origin, and this distance here, which maybe I'll highlight, so this distance from here to here is still 95. Okay, so I'm going to plug this in. I get y equals 47 over 15,625 times 95 squared plus 3. You can see that this time, if you look, that is the same equation as the one that I have over here, except that the plus 3 is already built in to my question. So when I calculate this y value here, I'm actually going to get the 30.147 meters above the road all at the end already. And that's how you do a parabola word problem.